Who has had a bit of a pivot in not only his company, but also in his personal career. Shaun Conway is a medical doctor who is now an entrepreneur operating in the digital space. Shaun, welcome.
Thanks very much. Is this on? Wow, that was awesome. So you might need a bit of time just to buy your solar panels. I'm going to talk about sovereign superpowers, and if I can just get this moving to the next one. So there's no doubt in this picture from Tiananmen Square, the student uprising in 1989, who the superpower is here. And it's no doubt that the unknown tank man had his identity known by the state, where he came from, how he got there, who he knew, and ultimately what happened to him. We only know of him as the tank man, and he certainly didn't have a Twitter account, he certainly didn't have a Facebook account, and definitely not a Snapchat account. So if we move forward now to where we are today, the superpowers have changed. So if we go beyond nation-state superpowers, we have the internet superpowers, the imperialists to which we are subjects, maybe slaves, our data is, all the information about our lives is held by around 6 companies. The majority of our data is held by 6 companies. They know who you are, how you got to where you are, what you're doing there, who else you're with, and when you're there. Now, this is a kind of crazy situation, and it's about to change. So yesterday we heard from Tanya about the Gartner hype curve and the huge number of technologies that are coming together. So other analysts have described this as the digital Big Bang. And this is not only about Bitcoin, it's really about all the decentralization technologies that are coming together to create an entirely new ecosystem, an entirely new economy, within which the data surface is going to be exponentially larger than what we currently have today. Now, who is going to control this? You know, who are the new superpowers going to be in this scenario? So if we look at the shape of things to come, we have the option of the sort of pyramidal power structures, the hierarchical structures that Andrea spoke about yesterday. Or we have alternatives that create a sphere of trust, that creates decentralized peer-to-peer options. Now, Leonardo da Vinci really believed in the power of, the power of man, and actually felt that man is the measure of the universe. The universe reflects the proportions of man. And he looked at ways in which man's powers could be multiplied. And so he invented machines. So now you could have the power of 1,000 birds, conceptually, and fly. You could have the power of 10 horses and go faster and pull more instruments and so on. So these were tools that could make us superhuman. And this was the start of amazing technological revolutionary thinking. But then look at where we are today. The tools we have are no longer multiples. They are exponential. They are information tools, like the hashtag, that can launch revolutions, cultural, political, and so on revolutions. And we now come to an important crossroads in terms of what these tools are and how we use them. And this is where we look at the current economic model, that the tools are provided to us as services that we become dependent upon, rather than tools that we use in order to exert our superpowers. So that's really what I want to talk to about today, and describe how we're building a platform for this using these new technologies. And so the new technologies are not just blockchain. They really are this whole realm of applied cryptography. I see this as being the kryptonite, okay, that gives us superpowers. And what's one of the important characteristics of cryptographic systems is that there are systems that are easier and economically less expensive to defend than there are to attack. This means that if I have these tools available to me, I stand a greater chance in front of those tanks, in front of those greater superpowers. And so this is really a hugely fundamental shift in who has power and how we use that power. And so we've been working on a protocol which is called the Consent Protocol, which is a self-sovereign protocol which allows for individuals to have a self-sovereign identity, an identifier that you own and that you control. And then to associate with that identifier information that you can provide access to on a discretionary basis. So this is privacy preserving. If anyone needs to know whether I am over the age of 18, they don't need to know my birth date, where I live, my name, or anything. And so I can selectively disclose information. And then this information needs to be trustworthy. If I say this is my identifier, I am a qualified medical doctor, how do I prove that? How do I use cryptographic proofs, hash functions, and so on, to be able to prove that? How do I notarize a record and place that into a public ledger? The system is essentially information-driven, and it's information-rich. So here we're not talking about big data, we're talking about really small data, but we're talking about high-quality data, like DNA. So if you have a record of your life that you accumulate your single source of truth, that becomes a highly valuable, highly accurate record of who you are. And this has hugely valuable opportunities and potential. Then this protocol needs to be interplanetary. Now, interplanetary is one of the protocols that you'll hear about when you start delving into decentralized technologies and Web 3.0, like the interplanetary filing system and the interplanetary database. What does this mean? It means that if I go to Mars, I should be able to assert my credentials. I should be able to digitally show who I am. The same applies if I go into the Deep Karoo, and the same applies in the Internet of Things when I go to step into a self-driving car, and I need to assert my credentials at that level of the car. So we're moving to a system of back to the edge, completely decentralized, and the ability to go and self-assert credentials and identifiers and other information about ourselves. And lastly, this needs to be persistent. So the blockchains that we're using today are not necessarily, most likely, not going to be around in 20 years' time or 50 years' time. And so the identifiers that we create and the data collections we create need to be able to navigate through these changes. And they need to also be resistant to quantum computing. And Andreas's article and presentation on that, it's a sort of great demonstration of how these protocols can achieve that. So this is not all set in stone yet. This is work in progress. So in order to build a platform that is interoperable and that's useful to everybody, we need to have open standards. And these are open standards that are being developed through consensus processes. This here is a snapshot from the windows of the Microsoft reactor in San Francisco from October, where we were participating in a technical working group, defining what are the technical standards, for instance, for a decentralized identifier. What are the technical standards for hosting a personal data store? And some of this has been resolved, and it will go through to become the new Web 3 standards, and others still work in progress. But the important thing is that this is open, it's interoperable, and it is creating the new platforms and the new protocols for the future. And it's happening now. So if we look at what the architecture of this looks like and how the protocols come together, it's really centered around an individual. And so at the core of it, you have your data and a mechanism through which to provide trusted other parties access to your data, to read, to write, to change your data. And this needs to come to an identifier. So you need to be able to root, discover, and come to this and identify this data. And a communications level through which that data can flow, a secure communications level. So this is really the core architecture that one can then start to build very powerful tools on. Because if you have direct access as an application developer, developing a thin client mobile application, for instance, you can speak directly to an identity, get permissions to go in and read and write into that data, And the person can even give you a space to write your app data into their database. So this is a really revolutionary new architecture for the web going forward. And it completely changes the power dynamics and the dependency on external services. And so what sort of self-sovereign superpowers can we imagine this giving us? Well, imagine the superpower of knowing who I can trust, even in a trustless system. Being able to transact across the world and know that I can trust the service provider or the source of information across the other side of the globe. This should allow me to live longer and healthier. So if I have all of my data in one place and I'm able to mine that data and detect health risks and other things that are going to increase my well-being and reduce my risks, this should impact on my behaviors and change my outlook on how long I'm going to live. We should be able to transact without a middleman. We should be able to rent our bedroom without requiring Airbnb. We should be able to offer a ride without Uber. And I should be able to access all of my information instantly. So do these sound like superpowers to you? Ultimately, the power of creating more time. So if we're not having to fill in forms all the time, remember our passwords, manage all of the data for the organizations that we rely on that supposedly service us, we're creating more time for ourselves. So I believe these are just really the sort of tip of the iceberg of a whole lot of really superpower applications that we will be able to create. So I'd like to just delve down a little bit more sort of deeply into this data layer, because this is really the core of it, it's the information. So through these standards, we're implementing a deterministic semantic data structure, which is based on international standards. And through new Web3 protocols around linked data, we can link via different schemas. So this really resolves very nicely into a standard data set. Now, this data, which we call my data, can contain all the kind of attributes about myself, but it can also contain the information about my car that I want to sell. And I should be able to put this available as an offer from within my data. And if I make it available as a public offer, web crawlers and search engines should be able to easily discover this and should be able to provide access to that information to whoever is looking for it. So I'm not relying on another service. I'm making available to the world information that I'd like to put out there. Equally, we can store credentials. So I can have a verification of my medical qualifications, which allows me to walk into a pharmacy and write a prescription, for instance. And these credentials can really go across all aspects of our lives. And so they are claims which we can make about ourselves, which can be trusted because they are verified, and they are formatted in a way that is non-repudiable. And the claims can be anything from I am KYC compliant as verified by This Is Me, or I have a 7-year no claims history on my car insurance. And so these digital assets become tradable, become keys that give us access to benefits and privileges and so on. And this is the basis for a much broader understanding of digital identity. So 2 years ago, PwC published this paper, Digital 3.0, the platform for the people. And they said that this empowers people to create new attributes, to share these attributes selectively as they connect with others, and create experiences and value beyond what can be predicted. So what I'm proposing here is that with this new infrastructure, with these new protocols, we are creating the potential for superpowers that we don't even yet know what they will be. So no internet conference is complete without the RAND Corporation diagram. From this, we understand what centralized is, but I don't think this is a particularly useful graphic depiction of the functional aspects of decentralized networks. So just to kind of go back to a relatable experience. When you want to transact with a counterparty, send them some value, share information or whatever, in most of the services that we use today, we have an institution, a central authority. And this creates a lot of friction. This creates the kind of problems that we've been talking about over the past few days. What we want is, and what we can get, is a transaction space or an interaction space that is effectively zero. So these days, if I WhatsApp somebody who's traveling, I have my son traveling in Germany, I can know that he just enjoyed a great burger. And literally the moment it hits his stomach, I know that he's enjoyed that burger. That's zero space. And if I want to send a transaction, a Bitcoin transaction, zero space. A little bit of time, but zero space. And so I propose that the new architecture is actually more like a sphere, where it's very difficult to demonstrate zero space in a picture. But imagine there is no space between any two nodes on this sphere. And the sphere is based on a trust protocol, a coordination protocol, and a matching protocol. So these are the protocol layers which involve the protocols. These are the protocols that we use in Bitcoin in terms of consensus, in terms of a trustless system that we can trust, a coordination protocol in terms of the data, the communication protocols that we use, and matching in terms of the data protocol structures. Now, where we have a coordination happening, for instance, through a common ledger, the effective distance between two people on that ledger is zero. So that's why when we're all on a Bitcoin ledger, the effective distance is zero. Now, we heard from Adrian yesterday about the interledger protocol. So this can bring different ledgers together, and so we make the circle bigger. And so the point here is that we can create exponentially increasing connections between people using these protocols, and allow for all kinds of new value exchanges and information exchanges. So how are we using the Ethereum blockchain? So I want to just, for a second, talk about digital identity. I think there's a lot of misunderstanding of what digital identity is, and we heard some comments yesterday suggesting that digital identity is not really something that we want to get into. Our understanding of digital identity is that it starts with an identifier. An identifier is a unique number, for instance, that we place into a public record infrastructure like the Ethereum blockchain, and this provides a discoverable, routable address from which you can then route to my data. So pretty much at the first level, the blockchain for identity is about namespaces and routing in a decentralized routing kind of model. And that's about it. If you have that in place, you already have powerful decentralized capabilities to be able to create an identity that is discoverable and that can route to your data and the data objects that are contained there. But we also use the Ethereum blockchain to create smart contracts that enable those agreements, those information sharing agreements that we put in place, digital agreements that say who the counterparties are that can access my data, what the terms and conditions of that are, for those agreements to be notarized and to be managed via smart contracts. Potentially, we use this as well for trust anchoring. So, for instance, to be able to take a notarization of a credential and place the hash of that onto the blockchain. And then there are other uses, such as now going into transaction billing. So you can monetize the use of your data. If I exchange my data with somebody, it can be on the terms that I need to be paid. And the blockchain provides a very efficient way of running the billing engine around this. We can issue a crypto token, and that enables the coordination within the community to happen, incentivizing information exchanges and so on. And then this links into the whole ecosystem of decentralized applications. So once I have my Ethereum identifier, my identity account address, I'm able to then transact within this kind of crypto world. So I'd like to then just finish off with a couple of examples of how we're using this in practice. So consent is being applied in a number of use case reference applications. Consent is the protocol, and as I said, this enables you to build thin client applications on top of the protocol. And the first of these that we have is called the Life Key application. And this enables me to connect with all of the accounts that I have, that I interact with, my bank accounts, my internet-based services, and connect those accounts into my personal data. And on that basis, I'm then able to, having authenticated myself with each of those accounts, use those as additional identifiers that can prove my identity in the context, in different contexts. With a connection to accounts that also provide an API interface, I'm able to show, to exchange data from that account into my personal data via a standard API interface and using the information sharing agreement permissions that I establish. This is also going to be useful for filling in forms, for instance. So I can go into to my GP's practice and see a QR code on the desk, scan it with my Life Key app, and all of the information that I would normally have to spend time filling out on a form can be packaged and sent across automatically. So this will save time and also provides verifiable information to services. So that's one set of applications, and we're hoping to get that application into the marketplace by the second half of this year. And so this provides the digital identity. It provides or draws on the digital identity capability of the platform, the personal data storage. It provides a personal API that I'm able to connect with services, and it enables me to put in place information sharing agreements that are fully compliant with the data protection and privacy laws. So it's fully POPI compliant, fully GDPR compliant. Every information sharing agreement generates cryptographic consent receipts. And so there's a log, an auditable log, and proof of the information sharing. Those receipts form the control policy that enables access in and out of my data, and I'm able to turn the receipt on or off. And then within my data, I have verifiable claims, and there's a standard sort of Web3 protocol or specification around how to configure verifiable claims that have digital cryptographic signatures that make the claims non-reputable and also show who has actually verified and attested to these claims. And lastly, we have a trust assurance scoring mechanism, which probabilistically says how likely a data point is to be true and positive. So the last use case that I'd like to talk about is called Ampli, and this is in the context of early childhood development. And so we're working with the Department for Social Development and partners. Our partners are the Innovation Edge and the UNICEF Innovation Fund. And what Ampli allows us to do is to connect children to preschools, and for the preschools to then connect to funders who will pay for the service delivery for early learning programs. It also enables funders to put out offers to preschool services and fund the delivery of preschool services. Now, this is really a hugely necessary service and an important space. It's very decentralized in South Africa. I don't know if any of you know about early childhood development centers and preschools. There's many thousands of them across the country. Many of them are sort of very small, informal services. And there's a huge need to improve the quality of these services, to connect these services to funding, to the government subsidy scheme for preschool, and to start to track the outcomes of the service delivery and developmental outcomes for the children. And so what we do with Ampli is we provide verified identity registries of the service providers, the children, and the ECD centers. And we provide proof of service delivery through kind of like a proof of work mechanism. So it's a secondary issuing of a token, the AMP token. And this happens when let's say a preschool teacher says, I have looked after 10 children today. They can issue AMPs and essentially create a token. And then we provide an automated claims processing smart contract or an oracle that looks at the data and the metadata that comes out of the application and verifies that that service actually took place, and then enables a marketplace to take place through an exchange mechanism where those tokens can be paid for by government or by other funders. Through this process, we collect data which is stored in people's personal data stores, and this enables tracking learning outcomes over time and creating records, developmental records that will be with the children as they grow older. So I'd like to just kind of lastly propose that we all have the opportunity to exercise superpowers. Some of these superpowers are the sort of the kryptonite that these new technologies provide us, but they also come from our own motivations and what we want to do in the world. And I've heard a lot of this vision in this past 2 days around what we can do that is possible and what these technologies are making possible and how we can harness these powerful tools to change the world, to be the world we want it to be.
Fantastic, Shaun. Thank you. Any questions?
I want to find out, in creating this kind of platform, what level of validation goes into this, especially coming from the personal, the various individuals that may have to subscribe into this for you to create the value in it to, say, other organizations. How do you ensure validation of this, or how do you make that happen? And what is the incentive in it for the individuals to actually present the right information?
Yeah, so we don't take any stand on a claim that an individual makes. An individual can make whatever claim they like. I can say that I'm a refrigerator if I want to. A refrigerator can say that it's a refrigerator. But these claims, we provided a protocol method through which claims can be recorded. So I can say, my name is Shaun, I am trustworthy, I'm creditworthy. You can make whatever claim you like, or other people can make claims on your behalf. And how the system then works is that external verifications are then asserted on those claims. So if the issuer of a claim, let's say the bank issues you with a bank account, in their golden record, your name is associated with a bank account number. And if they sign that claim, they say, yes, this is the bank account number for Shaun, and they sign it cryptographically, they are a source of truth on that claim, and a trust anchor on that claim. And that then starts to add weight and likelihood that that claim is true and it's positive. We believe in a distributed trust or decentralized trust authority mechanism. So there is an initial phase through which you require central trust authorities like banks and government and so on to provide the initial claims. But once you start to get into decentralized peer-to-peer interactions, the peers around me or my GP or my employer can also assert claims. And the trust levels of each of these peers influences the weighting of how that claim is then statistically, probabilistically determined to be true and positive.
Thank you for a great presentation. I don't know if
We can hear you. That's great. With the mic.
the mic is okay. Okay. Couple of questions. So, the first question is, I think this is a protocol that you're trying to build. Is that correct? And so the question is, kind of, what's funding it, and is there a revenue model, or is this just a distributed app that's kind of out there for people to use? That's the first question. And the second question is, other organizations like Civic and other dApps like Uport, that's built by Consensus, are doing similar things. So does this compete with those protocols? Or is this going to be kind of complementary? How does that work?
Yeah. So first of all, these protocols need to be standards-based and interoperable. So we're one of around 5 of working group that, for instance, that developed the decentralized identifier standard, including Uport and a couple of others, who have agreed on this being the standard. And so we're all implementing that in our systems. What each of the implementations of the protocol do is they define how it gets implemented and the business case of how you get that into people's hands, into users' hands. Now, my view on this is that the more organizations that are able to find ways of how to get this into people's hands, the better, because we need to really kind of completely reboot the way that identity is managed and provisioned within society. In terms of the other components of the protocol, we are building the software that runs the protocol, and that's also mostly open source, so personal data stores and so on. Most of it is work in progress that is going to change as the decentralized technologies become more and more robust and can be taken into a production environment. So we have a hybrid of sort of conventional and decentralized Web3 standard-based code. And then in terms of business models, there is a business model around executing the protocol as a service. So we would need to compete with any other executors of the protocol on price and efficiency and so on. But there's also value adds such as the trust assurance scoring, which, like Google search, getting in early on the game, you have the sort of longest machine learning history on that and the greatest data set. And so you become better, your algorithm becomes better than anyone else's to provide that kind of value-added service. And then there are some other components around helping people to compile their claims or their digital assets and managing that through provenance chains and so on. Yeah.
Great, thanks. We're out of time, so please feel free to catch up with Shaun a little bit later over lunch. Thanks, Shaun.
Sure.
Thank you very much.
Thank you.
Presentation.